Well, hello everyone. Welcome back to FancyGUI, the fanciest channel on YouTube. So today we're going to be talking about how container images actually work and what does it mean to actually build one and use it. To do that, I have prepared here a Rust little application. If you don't know Rust, don't worry about it. This is just a tiny HTTP server, literally, as we're using the tiny HTTP library here. And all that we have to do here to show you how it works is just do cargo run. And then I'm going to open a new terminal here, do a curl on HTTP localhost and 8080, and it just says hello from the tiny server. That's all that it really does. So now that we have this little fella, we can try to build a new container image for it, shall we? So let me just double check your recording. And yeah, we're good. All right, good. So now first let's create a basic container image for this. So let's add a Dockerfile. And it is Dockerfile, we have to call it from, so which image, the base layer, and keep that word in mind for the next time I say that, is the Rust image. So I believe the latest one is 1.9 something, doesn't matter, I'm just going to use Rust for now, just uses the latest one for now. Then from here, we can copy our files, so from everything from here to the container localhost, we're going to put that into a working directory that we're going to call data app, and we copy it there. And then what we can do is run a cargo build. So what it does for the cargo build, let's do that here. It builds that profile of dev right now. Let's do release. There's a reason for that. It's just that it removes most of the dev bindings, so the actual profile is better. So it got generated, and now if you look into our target folder, and let me open here so you can see that, we should have now a target folder and a release, and in there our tiny little server. The name tiny comes from the tiny package name here. That's all it is. So now what we can do in my local machine yet, we're not talking about containers, this runs from target, release, and then there is the tiny little fella. And that's it. So same idea, and if we go back here and then curl, hello from the tiny server, same thing. So that works. Now, we have that running. We can do a build, and then we're going to do a release type of build. And what we're going to do is tell it that to run this, oh my goodness, to run this container, we are going to run that through the command of that executable, which is target release. And since this knows the relative path from my local folder, and the same one is essentially out there into the released version, we can just say release tiny, and that's it. So now that we have that, we can do Podman. Don't worry, if you have Docker, same command, just switch Podman to Docker, and then we can do build test, and that's it. So it's going to pull that latest image from Rust that comes from the docker.io or Docker Hub repository. This is the default one, and it downloads it to my machine. And you can see that it takes a little while, right? Because this image, it is not as light as one might think. But we're going to get there. And it downloads, copies the blobs. Now, goes to our working directory, copies all the files, and then runs and releases. Now, I could not find cargo tunnel in the app or any prior directory, but found cargo.toml. Please. Oh yeah, right. The latest version of this asks for a cargo with capital C. And let's go again. Now you're going to see something really cool, that it was much quicker to start. That is because the first layer, and I'm going to show you right here, it has been cached. So see step one from, it didn't download it anymore. It's in my machine right now. But still, we went to that working directory, copy the file, we built that file, and it runs just fine. Great, right? So now I can do podman run name here. This is a test image, so I'm going to call it demo image. Let's do tiny. And we're going to do in my port of my localhost of 8080, forwarding to 8080 there. And the name of the image we call this test with a tag latest, and then we just run it. Written array, but is using quotes instead of double quotes. Oh yeah, right. So let me just do double quotes here. Sorry, that's just me jumping between languages. That actually might be the case because it did not build. But here we go. So again, made a little change, copied everything, ran another build, and now you can run. Alrighty. So, oh yeah, so because I created that one, so if I go Podman PS, you can see that it's not there, but if we do -a, you're gonna see that there's a bunch of images there. So once the container stops, it's not really gone. We have to properly delete it. So Podman RM, and then what did we call that? The demo, tiny. There we go. Now we can run it. So let's run tiny. Podman run tiny. There we go. And now it's listening. And then we can run it and curled against it again. And hello from tiny server. And it works the same as we'd expect. It's working perfectly fine. It is really performant as a container should be. And now let's go to, and pardon me because my terminal doesn't like it. Podman stop tiny. So let's stop it because it doesn't want to stop by itself. And now what we're going to do here is let's take a look at that image that we've just created, right? Let's just see what he has and see if it's actually stopping for whatever reason. Oh yeah, it did stop. Just took a little while. So what we can do, history, tiny, or test, sorry. Ooh, you know what? Let's grab a new image name because this image name is a little bit, it has some historical things. So tiny web. Let's just call it tiny web. All right. Did you see how fast that was? Everything was cached. All beautiful, right? And let's go and look into Podman, inspect, image, history, tiny web. And let's look at that. So here's the important bits that you have to think about. This image, it has a history of making changes based upon those things here. Now, you can see some of the things that I've added to my Docker image. The working directory, the copying of the directory itself and the size of it, and then the build itself. But there's this base image here. And you see how those layers here are 2 weeks ago, 5 days ago, but I've just written this image? Well, this is the beauty of it. We're talking about layers here. We're talking about how containers are built. So containers is essentially, they're just a read-only stack of layers with a writable layer. What does that mean then? All right, so let's take a look at that. So let's say we go to, let's get rid of this guy now. Let's go and run a Podman run. Let's call, doesn't matter. So let's IT, because we're going to be iterating there. We're going to run that without ports, doesn't matter. And we're going to run Ubuntu here. And then I'm just going to go and attach myself through bash. Here it is, right? So this is a Ubuntu system running in a container, and I'm attached to it. Now, if I run here and do a ls, you see I'm here. Let's go to temp, and nothing here, right? So I'm going to touch a different file. And now, if you do ls, different file is here, right? So there's something here. Now let's quit and do Docker and do Podman run Ubuntu bash. Same image. So the image is Ubuntu. And I'm going to bash. And I'm going to temp. Do you think the file is going to be there? And like magic, it is not. The thing here is, there's a difference between an image and a container. The container uses the image and the base layers that have been defined into the metadata, into the layers of the files that were there done in the file system. And then you can run that into a writable interface, which is a container. So when I ran the second container here, I essentially created a different one. And this is further, and this is easier to understand just by looking at the name of the computer here. You see there's a 5E3B, whereas this one is 2B22. So they get attached to a different container and they're isolated by default. This is the beauty of it. Whenever I run this container, I get a fresh one all the time. Now, there are many ways to actually make it more usable. And what do I mean by usable? This looks fine, right? But look at this. Let me show you something. So if I do Podman image list, and then I find my, what was it? Tiny image. That tiny web image is 1.6 gigabytes. And this is a cargo, this is a Rust binary. That doesn't make sense, does it? Now, let's look into how we can further understand what is going on here, right? So remember when I built this and, not cache, Podman build tiny web. See how everything's cached? Now, look at this. I'm using a cache from the Rust base image. I'm putting that into, I'm going to a directory here, whereas in which I'm building that image, copying all my files, building that image, and then running from there. Do we care about all of those things here? Furthermore, let's look into how that works, shall we? So let's say for whatever reason now, I want to change, and instead of saying received request, I just want to say, I don't know, request. So this is the request that came on, right? And instead of just giving the content type, header invalid, I would say header invalid, please ensure that you are sending the right binary bytes. Good. And I'm just making changes here, some text, so it should be pretty simple to change, right? So let's see how that, So let's see how that gets built actually. So if we try to build it again, wait, what's going on? It's compiling everything, it's copying everything over again, doing the whole shebang. Not very efficient. Why is that? Well, if we go and do Podman image, Podman image history, tiny web, we can see exactly why. From the bottom up, we can see exactly what has been done. So this is where it comes from, this image, and these are all the changes that have been done on top of it. Imagine that as being a difference. So a difference between what was and what is, and what made that change. And this is it. So we started off from this 146 megabyte base layer, and we're building on top of that by running some scripts, and those scripts are installing using Debian, whatever that is necessary, downloads the 653 dependencies probably for Rust, and then here actually installing Rust and using the base layer, right? And that makes that base layer that we're using here. And then all that we're doing here really is just adding that 26 megabyte base layer. 26 megabyte difference of layer in which there is the copy of the whole thing. But still, 26 megabytes. That is not great. Essentially, all we need here is a portion of what was generated from this release. Also, why are we fetching all the dependencies all the time? Why aren't we just caching those out? So let's look into that. So this is our first iteration here, right? What if I wanted to do something, let's say, I wanted to prepare things before I moved my files. So whenever I move my changes, I don't have to change all that much. And I'm saying change a lot. Let's see, let me show you what I mean. So instead of copying everything, let's get started by copying the cargo toml file, as well as the cargo lock file. All right, let's copy those over. So that is the prep work to fetch the dependencies so we don't have to download those later on. So what we can do is just here download these guys and do a cargo build. Just a quick cargo build of whatever it is in here. And let's for now. And then once I'm happy with it, I can do copy of source into the folder here. And then I can actually properly release. So let's look into how that goes. Podman build tiny web. So now I'm building that stuff out. Why is it? Oh, right. This is not right. We don't need to build like this. We're just building this guy as this. Now, because I don't have any source or anything, this is just a base layer of grabbing things. We need to get at a fake layer so Cargo can run and pull all the things and actually do a pre-packaged build. So we're going to run, I think I can run make dir source, and then I can do echo function main, and here we can put that into the source main.rs, and now we can build. Good. All right. So once we build that here, we don't want to actually have the problem of trying to overwrite. So what we can do is run rm/rf and the source folder, and now we can copy and build it again. But first, don't forget, run cargo build release. Good. Now let's try it again. Why doesn't it like? Oh, cargo build here. So yeah, no, here. There we go. Nice. So see, it's creating an index, it's downloading the index, downloading the dependencies, building everything, and then it's gonna try to do and run the building and releasing with a fake one. That part works great. And now I am removing that source file folder, and then I need to copy that source folder to the source folder, right? Am I going crazy here? Yes, I was. Okay, cool. So yeah, just making sure, folder to folder, file to folders. Anyways, this is what it does. Now, see how quick that was? Now, let's say if I wanted to change something in the main.rs, and now make another change here of request made, and try to do a quick build again. Did you see how fast that went compared to the other build? And if we look into Podman image history, we're going to see something really interesting here. Now we have only 936 kilobytes into that top layer, which does the actual build. And we're only copying really the Rust file that is changed into the main folder. So all the changes that we're doing here, they don't depend on this cargo build release that downloads all the dependencies. So now we have a faster and more granular way to build your layers, in which is going to be much easier to understand once we look into the folder files actually that it does. But let's improve this, because now if we do image list, then we find this tiny web, it is still 1.6 gigabytes. And for a Rust package, it doesn't make sense, does it? Not really. So what can we do? Once that's built, and if we look into that file, into that image here, so we do podman run it test, I think it's test, no, tiny web, and let's go bash again. But now we're going to get into that pod. So let's look into what we have here. We have that cargo tunnel, the cargo lock, source targets, the whole thing. And if we do ls-al into the target and release, you can see that the actual tiny binary is here. And that's all really we need to run this image, right? So what if, let's get rid of this guy here for a second. What if in this Dockerfile, we just, rename this here as a, I don't know, builder to build something. And what we can do, let's not run a command or anything right now, but let's say we do a from, let's not say scratch for now. Let's say Debian. So Debian, it's a tiny little machine, or Ubuntu really. Ubuntu can be tiny too. Ubuntu. And let me show you here. So if we go into Podman image, wow, image list find Ubuntu, you're going to see here that Ubuntu is only 103 megabytes. Still super large. Maybe Debian's better. Podman pull. Let's do Debian. Otherwise, Alpine, maybe. Debian. Debian's 100. Holy moly, no. Podman pull Alpine. Alpine is going to be definitely much smaller. So let's do Alpine. All right, that's better. Okay, 8 megabytes. So this is the whole base layer of Alpine to run my things here. And I'm choosing Alpine instead of Scratch for a reason I'll show you later. But let's say here, Alpine, and this is my actual image that I'm running from. And this is another base image in the same file. It's going to make sense. What we can do here now is create a working directory, same way as we did in the other guy. But now what we can do is copy, and what we can do is copy from, and then builder. So now what we do here is we're copying from the builder image, so the one that we're building above, and we're going to copy the target release tiny. And we're going to copy that into here. And now all we have to do is run the executable here. So what we can do is app tiny. So let's look into how that goes. So now if we do podman build that tiny web image, it's going to do the whole step of building, and everything is cached, and it downloaded the Alpine, and it just really copied. So that was very quick. But, well, actually, it didn't like it. So checking sources under copy your stats, release tiny, no such file. Wasn't it? Sorry, podman run tiny web. And if we do here into target release, relative here, I want to have app. That's probably what it was. It's just a relative path that he doesn't understand. So do it here, podman build Alpine, copy actually runs now. And now if we do podman image list, and let's look into tiny web, 9 megabytes. And if we run it, podman run port, nope, podman run tiny. Oh, yeah, podman remove tiny, podman run tiny. It's running. So now we have a 9 megabytes, an image that is properly formatted, so it doesn't have to do all of the builds and the fetching of dependencies all the time. It just copies the source folder. So whenever only cargo toml or cargo lock changes, that it's going to go back to this layer. It has already cached layer of Alpine, and then it just grabs whatever is built from here and runs it. And that's it. That's all you need to have a running tiny, super efficient container image. Now, bonus points. Now we're just running a container image, we're using root, we're using this base layer. Say we want to make it even more efficient. Because right now, and let me show you this, we can still go here, and of course it doesn't stop again. I have to figure out what's going on here with my podman, but that's something for later. So we can do stop the tiny machine here. So this tiny app here now, it runs on root. So right now, if you check the runtime process of this, and let's do this in podman run, just the same tiny app here, but let's do a port forward here. Sorry, podman run tiny web here. But instead, I'm going to just detach those guys because it doesn't matter. Sorry, tiny web. Yeah, I don't care about these here. And now if you go podman ps, we have it running here, Hopefully. Not really. What's going on? Podman build. Tiny web. Go. Yep. Tiny web. Go. Did it not like tiny? That might be it. Podman ps logs, because you can do that now, and then 3e, which is the beginning of the image name, and then we can see what is going on here. So for whatever reason, I believe I have built it in a wrong way. But why is it not liking the things that I have built? Request made here. Hello from tiny server. Great. Podman build, tiny web. Let's look into the layers here, see what we might be missing. App target release tiny. Copy that to the app folder, and then run as app tiny. Okay. If we do here, build, well, it's built, so it's all cached, doesn't matter. Podman run. Instead of detached, let's just say no such file or directory. App.tiny. Okay. Maybe did I save it? Really? I think that was it. No, app tiny. Okie dokie. App tiny. Yeah, he doesn't like the directory. So he grabs from builder app target release tiny app tiny. I am pretty sure I'm just missing something here. So let's go back here, and then now we can just go back here. Let's go back and create these guys here again. So now if we do Podman build tiny web, sorry, not tin web. Let's do tiny, because that's what we want. Tiny web here. Same thing that we've done before. Podman run tiny web bash. Might not have it. That's fine. SH. Much better. Okay, cool. And we have tiny. Okay. So if you do tiny, did it create a folder? Oh, it did create a folder. Okay. All right, cool. That's fine. So it means they created a folder. I can put that into app. Just exit here, Podman build. And builds that again. Because they just changed the latest piece. It's going to be very quick. Podman run. And then tiny web. And now we can do tiny, cd tiny. Nope. Wait a minute. Yep, LSLA. Tiny. Not found. Yeah, it's definitely here. For whatever reason, did I build it on the wrong thing? Oh, I did. Okay. So if I do Debian instead, oh, because it's not a muscle runtime. Okay, there's a difference. I'll talk about it. So let's go Podman build. We're going to use a different base layer. The base layer is because of how the image is built and how it runs. Because I built it on Debian and I'm trying to run on Alpine, it doesn't really work that way. It's not the same, but think about trying to build it on Mac to run on Windows and vice versa. It really doesn't translate well. So now let's try to run it again. Now if we go here, we have tiny, and then we can do tiny to run, and now it runs. Goodness gracious. All right, this runs. So now we have tiny running into there. And we have a much tinier image. So if we go Podman image, history, tiny web. Now we have really essentially the Debian base layer, as well as the commands of copying the file, which is 900 kilobytes, which is essentially all the server is, and running it. That's all you need. And now you have this much simpler version of that app to run. So you have the image, which is super simple, and the container, which grabs those layers and runs it. And now you have something nice. But, all right, Guy, you've been talking forever now, but what is this image really? So let's try to save that image. Podman image, save. Let's save this tiny web image into a test.tar file. Yep, so we write that test.tar file. If we see that here now, it's the test.tar file of 146 megabytes, so it's just as big as that image essentially. But if we do tar, well, tf -tf, it's going to show us the files here that are inside of that tarball. Tarball is essentially a compressed file, so a zip file or a RAR file, as you might be more familiar. And if we go here and look into the files itself of it, here it is. But if you look here now, you see all the layers that compose these actual tarball file that composes your image of what it does. So because it is formatted in this way, what we can do is tar xvf. Let's do and export this guy here. And let me show you the layers of how they actually look like. If you look at the manifest.json, but if you look at the layers here now, we have a definition. This is essentially all the container image is. It is just a manifest that tells you, hey, this is where the name of this repository and its tags. This is the configuration, where the configuration file is going to come from, and the layers that you have to build on top of that. So let's look into this. So there's the F5FF. This tells you when it was created, which operational system it was created for, which variant of that operational system it was created for, some environment variables, the command line to start, the working directory, the whole shebang. And the really important bits here are the rootfs. Rootfs here is just tells you the root, which is the beginning, the first slash, is built on top of layers, and the differentiator IDs, so the differences between file to file, are using these hash files. This is how Docker knows, how do I apply those layers? Which layers are being set, and what are those differences of layers generating? So they do a hash. And if you want to hear more about hashing algorithms, this is a whole other topic on itself, but essentially it just creates a hash on those differences, and then it just, has this ID, which is consistently different from everything else, so it knows how to apply each layer and differentiate those. And this is it. This is your image. This is how you run it, and this is how you package, and this is how it's saved. This is how it's meant to be looked in your system. And what's even more fun, so let's go here and first let's clean out a little bit these guys. You don't care about these. Yeah, these are the repositories where it runs. I don't care about this guy anymore, and I don't care about this guy anymore. Good. All right, cool. So let's do something even more interesting. So you remember how we have this file and how it runs? Let's say for whatever reason, I want to keep something else alongside of that tiny little container, right? So if I do podman run tiny web on sh, and if you look here, we only have tiny, right? Let's say we have a touch here, and then we touch that with another file, right? And now we have another and tiny. Remember how we exit, and now we don't have that file anymore? What if, let's do podman ps, and then show all these containers, and this one that we just exited 10 seconds ago. And what we can do is podman commit, and we just say, hey, commit this file. So if we go to here, podman image list, and we look into the images that were generated, and I want to grab the first ones here. And about a minute ago, I created this new one with no repositories, no tags. This is just an image that we have here. And we have this guy. And then we can do podman run it, because I want to see what's inside. And then sh. And now we have that committed into this image. And because of that, if I wanted to make those changes, and now I want this file to be in the outcoming image, I can do podman tag, and then I put this image, and then I do tinyweb v2 for whatever reason. And that's it. And now when we do podman podman image history, tinyweb, you can see that, tinyweb v2, you can see that now I have here 2 minutes ago a added file in which I've created yet another layer on top of the previous layer. And that 5 kilobyte change added all the differentiations between those two layers to make sure that that was available next time I run this command and next time I run this container image. So now from an image, we created a container, we layered on top of those, we wrote a file on top of that, we committed it into another container image that became another runtime here that we have. And this is very powerful because now you have the building blocks and the understanding of how to create those images and show to whoever needs to know, and you can understand now how to build your images based upon these concepts, right? So containers are based on layers. The ordering of those makes the caching and the differentiations between those layers work better for you. So you're never going to copy everything and then run all the commands right after, because that means you're not going to cache anything. You're not going to reuse your layers. And once you get something out of it, and especially for compiled languages like Rust and C++, you can just move tiny binaries and create an easy runtime. And this is how Docker, containerd, or any container runtimes and building container images, this is how it gets so powerful, because now we have a repeatable way to run your application in an efficient way, in an isolated manner, every time, everywhere, by building it like this. And this is it, everyone. I hope you enjoyed this video. It's a little bit on the longer format. It is packed with information. I know there's a lot more to talk about containers. Let me know if you have any questions down in the comments, and I'll see you guys in the next one. Oh, and don't forget to like and subscribe.